Good day, fellow. Setso is back. Today we are going to do the number pattern, the basic introduction to number pattern. By definition, the number pattern implies the sequence having same constant difference or ratio. The word constant implies same difference or ratio. Then we have three types of number patterns. We have a linear, or another word, arithmetic. Let us use arithmetic. Also have what? Quadratic. Thirdly, we have what? Geometric. Let us start with arithmetic. By definition, an arithmetic sequence or pattern has or have same, or let me just say have first, first constant, to be specific, first constant difference. See, the arithmetic have the first constant difference. You see? Then now I'm going to give you a sequence which represent arithmetic. The sequence that I'm going to take is this one. Let's say if I have 1, then let's say 3, then 5. Then I ask you to investigate if the following sequence, is it arithmetic or not. Then for us to determine if this one is it arithmetic sequence or not, we are going to subtract. Then bear in mind we have T1, T2, and T3. For us to subtract, in this case we are going to say T2 minus T1. It's like I say 3 minus 1, then I'm going to get 2. All right, 2 here. Then for us to get another difference, you apply the same principle by saying term 3 minus term 2. It's going to be 5 minus 3. You are going to get the same answer, which is 2. At this point, you can clearly see that we get the same constant difference. Then this number 2 will be our difference. Do we get the point? Then now let us move to another question. Let's say somehow they ask you to determine the nth term. The nth term is the general formula, or the formula of the arithmetic in this given scenario. For us to determine the nth term, we are going to use this general formula, which is Tn a n minus 1 d. You see? Then your d is your constant difference. Where you see a is your first term. In this case, our a is going to be 1, first term. Then let us substitute for us to determine the nth term. So simple. When you see a, you place 1, say n minus 1 d. Oh, sorry, let me just erase this thing. Sorry. It's 2. Then you distribute 2 throughout. It's going to be 2 multiplied by n. Let me write 1 plus 2n. 2 multiplied by negative 1, we get negative 2. Then you simplify everything. Your final answer is going to be 2n minus 1. Then this one is going to be what? To be your nth term for this given arithmetic sequence. Then let us continue. Now, if I were to ask you this question to say, kindly determine term number 4, how are you going to determine term number 4 at this point? It's so simple. You can use your formula, or you can just continue by saying, okay, because now I know that my difference is 2. My constant difference is 2. I'll write 2 here, then say 5 plus 2, then get your 7. Or you can just use your formula where you see n and substitute 4. Then it's going to be T4, which is T, where you see n, you place 4 minus 1. Then we get 8 minus 1. Then your final answer is going to be 7. You see? This is another approach. Then now, let me continue. By saying now, determine which term is equal to, let's say it's equals to 199. Then how are you going to answer this question? It's not difficult. Where you see Tn, you substitute this value. Where you see Tn, you just need to substitute that value. By saying now, my Tn is going to be 199. Where you see Tn, you substitute that value. Then let us then solve everything. Where this is your end term. Where you see Tn, you place 19. Then you see 2n minus 1. Then you transpose 1 to the other side, you get 200. You see 199 plus 1. We took this 1 and transpose it to the other side. We get 200. On the side going to be left with 2n. Let us divide both sides by 2. Then we get our n to be 100. This means term number 100, its value is 199. You see? It's not that difficult. Then now, I hope you understood. Ne? For arithmetic, we have the first constant difference, which is 2 in this case. Our a value will always be term number 1. For us to determine the n term, we use this general formula. Then we substitute everything. Then for us to find term number 4, you can use your sequence already, or you can just use your formula. Then now here I ask you a question to determine which term is equals to 199. For you to determine term 199, you just need your formula. Where you see Tn, you plug in 199 there. Then you simplify everything. See? Then now let us move to another one, which is the quadratic. Let us see the quadratic number pattern. Let us see the quadratic sequence or quadratic sequence. The quadratic sequence have the, let me say, have the second constant difference. The second, not the first. The second constant difference. Okay, let's say if I have, let's say -4 with trying to create 1, then -3, zero, then lastly 5. Let us investigate. We have 4 terms in this one: term number 1, term number 2, 3, and 4. Let us investigate to see if it is the quadratic sequence or not. Do this process by saying -3, T2 minus T1. Then it's going to be term number minus, your T1 is negative, don't forget this. Then your final answer is, you can use your calculator if you want to. You can use your calculator by saying -3 minus -4. You get 1. Then you write 1 here. And let us continue again by saying 0 minus -3. Obviously, we're going to get 3 for this one. It's easy. We continue again by saying 5 minus 0. Our final answer is going to be 5. Then you write 5. Then we continue again by saying 5 minus 3. This one is so simple. We are going to get 2, then 2, exactly. You see, this is our second difference. This was our first difference. You see, our second difference, our first difference. The only constant difference here is this one, which is the second. Hence, I stated there that our second difference must be constant. Then how then are we going to determine the end term or the formula for this given quadratic formula? We are going to do it like this. Let me just erase this. I don't have a space. Let me write it here quickly. Let me write, I won't have a space. Let me write it this side. 0, 5, got 1, got 3, got 5, then 2, 2. This one. Yeah. Let me erase this side. I'm going to need this side. Then okay. Don't forget, the general form of the quadratic is like this: an squared plus bn plus c. You see, this is our general formula of the quadratic. For us to determine the end term of this, we need to find the value of a, the value of b, then the value of c. Then how are we going to work out this problem? It's so simple. For us to find a, we are going to equate this number, the constant difference to a. Then it's going to be 2a is 2. For us to find the value of a, we divide both sides by 2. Then we get a to be 1. See? So simple. Then we have found the value of a. Now let us find the value of b. For the value of b, we are going to use this one. It's 3a plus b is equals to this one. Then for us to get the value of b, we must use this formula, this expression 3a plus b, for us to determine the value of b. Now let's go. You are going to say 3a plus b is equals to 1. You equate it to this number, always this first number, which is equals to 1. Let us substitute a going to be 1 plus b is equals to 1. When you multiply this and this, you get 3 plus b is equals to 1. You take 3 to the other side, then we are going to get 1 minus 3, which is minus 2. This is your b value. For us to find c value, you must use now this one. It's so simple to erase. For us to find c value, we are going to equate that one to, let me write like a b plus c. See, we are going to say now we have a plus b plus c equals to minus 4. Let us substitute a, which is 1. Let me see. Yeah, which is 1. B, which is minus 2c. We don't have c. Minus 4. Then let us simplify. 1 minus, you get minus 1 plus c, which is equals to minus 4. Then you take this one and transpose it to the other side. We get our c to be minus 3. Then this one is going to be our c. Don't forget that our general formula was as follows: plus c, where you see a is 1 nx squared, cb minus 2n, where you see c is minus 3. Let us see if we got the correct formula. Then what are we going to do now? We are going to investigate to see if our formula is correct. Where you see n, let us place 1, term number 1. We must get the value of minus 4 if our formula is correct, by saying t1 1 squared minus 2 1 minus 3. You can just use your calculator to make sure that you are safe. Let's see, we have 1 squared minus, we have minus 2 1 with minus 3. Indeed, we get minus 4. Minus 4. Let us see term number 4. If we get 5, you take your calculator, where you see n, plug in, or let me just erase it, erase here, to see if we got the correct. We must make sure. Say t1, where you see, or let me say 4, where you see n, plug in 4 squared minus 2 4 minus 3. You will get for this one 1, then plug in 4 squared minus 2 open bracket 4 minus 3. Then yes, indeed we get 5. That means our formula is going to be this one. Then now let's say now I ask you to determine term number 5. How are you going to find the value of t5? So simple. At this point you can just use your formula. See, let us find term number 5. You can just use your formula. This is our formula. Tn is equals to 1n squared minus 2n minus 3. Let us plug in 5. 5 squared, don't forget the squared. Where you see n, plug in 5. Then you solve. Let us solve. 1, 5 squared minus 2, 5 minus 3. We get 12. Then our term number 5 is going to be 12, right? 12 there. T5 is going to be 12. T5 is going to be 12. See? Not that difficult. Let's say if you come across this question which says which let's say it says which term is equals to, let's say 45. Let's say you come across this question which says which determine which term is equal 45. How are you going to figure this one out? 45. Where you see your Tn, you just need to plug this number. Let's go. We have our formula as follows. Tn is equals to, let me just write n squared minus 2n minus 3. We plug in 45, n squared minus 2n minus 3. Then at this point, let us solve for n. Solve for n minus 3 minus 45. Going to get n squared minus 2n minus, going to get minus 48. Then now, for us to find the value of n, we are going to factorize. Let me put 0 on the other side. We are going to say n minus, obviously n plus. Let's go and figure out the factors of 45 and see if we get them. Then the factors of 45, okay, I think it's 8. It's 8 multiplied by, let's see if we take 8 multiplied by 6. 8 multiplied by 6. 8 multiplied by 6. Yes, indeed, we get 48. Then okay, we must put 8 this side, then 6 this side. Let us solve now. N is equal to 8, or n is equal to minus 6. Then now at this point we have two values, but we must cancel this one. Why? Because we don't have a negative term. Our term always starts from 1, 2, 3, 4, 5, 6, 7. Our n will always be a natural number, not an integer, a natural number like 1, 2, 3. Our term, we have term 1, term 2. We continue that way. Then this is going to be our answer for this one. Or you can just use what your quadratic. How? By saying, you can use a quadratic formula if you want to. Let me erase. Let me erase here. Or let me just erase almost every thing. 45. Don't forget 45. Yeah, you can just say they want us 45 plus n squared minus 2n minus 3. We got 0 n squared minus 2n. We got 48, ne? minus 3 minus 45. Yes, we got minus 48. Then for your quadratic, our A is 1, our B is minus 2, our C is minus 48. Then you know that your quadratic, in this case we don't have x, we normally use x, but now it's going to be n plus minus b squared minus 4ac. This is your formula, quadratic formula. Your b, open bracket, minus 2 plus minus, your b is minus 2 square. Then you see 4, your a is 1, close the bracket, then you see it's going to be minus 48. Ooh. Then 2a, let's say 2a, our a is 1. Firstly, we are going to consider a positive, whereby our root is positive. Then secondly, whereby it's negative. Then it's going to say 2, negative 2 plus root, open bracket, negative 2, you square, minus 4, our a it's 1, our c was minus 48, 2a it's 1. See, then we get 8. 8. At this point, we remove that root, negative, positive root, we make it now negative. See, we get minus 6. But we cancel this one out. We then take this one. Say T8 is going to be 40. Yes, we said 45. See, it wasn't difficult. Then the final one, quadratic, sorry, the geometric sequence, the geometric sequence. This is the sequence that has or have constant ratio. See, the term ratio, it implies to a fraction, one quantity divided by another quantity. Then now let's say if I have, let's say 1, 2, let's say 2, then let's say 4 here. Then I ask you to determine the given sequence. Try to figure out what type of a sequence is it. If you subtract, you won't get the constant difference. If I subtract this one by this, I'm going to get 1. This one with this one, I'm going to get 3. The only way that I must make sure that our constant is the same throughout, in this case it's a ratio, I must divide. How am I going to divide? I'm going to say now term 2 divided by term 1, which is 1. I get 2, you write 2. Then you say term 3, which is 4, divided by term 2. This one divided by this one. Same as this one divided by this one. Then we get 2. See? It's not that difficult. Then this time around, this one is our R. This one still remains at A. Then now let us figure out term number 4 without using what? A formula, and see if we can be able to find term number 4. Then for us to find the next term in geometric sequence, we multiply by saying T1 multiplied by 2, we get 2. 2 multiplied by 2, we get 4. 4 multiplied by what? 2. Our ratio is the same. Then we are going to get 8. let's see how then are we going to determine the n term, the formula that represent the geometric into sequence. So simple, we always use this one by a n minus 1. Then let us solve. A in this case is 1, r is 2, then you have n minus 1. See, it's so simple, so simple. Then you have tn. You can leave it like this, it's fine if you want to. You can leave it like this, you still get the same answer anyway. Then let's check if we substitute 4, are we going to get 8 there? If we decided somehow to use the formula 4 minus 1, 4 minus 1, you get 3. 2 to the power of 3, yes indeed, we get 8. Term number 4 is 8, same like that one. See, then suppose if I ask you to determine let's say if I ask you to determine the term which is equals to 32. Let's say I ask you this question. You say now, kindly determine the term that is equal to 32. Don't forget, whenever you come across this question which says equal each and every time, where you see your tn, you substitute that number, which is 32 in this case. Then let us consider our formula from here. It was tn equals to 1 n minus 1. Then you substitute 32, 1 multiplied by 2 n minus 1. If we divide throughout by 1, still we are going to get 32. It won't change, n minus 1. Then now at this point we must write our 32 in a form of prime base. Then how are we going to write this one in a form of prime base? Then you are going to take your calculator and press 32 equal sign, then press shift, then fact. You see there's fact there, fact, then there's your answer. It's 2 to the 5. Right, 2 power 5, then n minus 1. See, we have same base. Then we drop our exponent, which is 5 n minus 1. At this point, so simple, because you just need to take your 1 and place it that side. Then your n is going to be 5 plus 1, which is 6. Then our term number 6 is equals to the value of 32. You see, this was just the introduction of these 3 sequences: arithmetic, quadratic, and geometric. I thank you. Oh, and again, if you are new to the channel, kindly subscribe and don't forget to hit that button for more. Then I thank you. Enjoy.